Hello, Afton, or specifically Pre-Calc. I was like, how you doing today? Let's go ahead and get started with today's lesson of sum and difference formulas. So we're not quite done with our trig graphing. I'm going to come back when we're in person, look at some things more specifically, but I figured we could go ahead and move on to the next thing. So ultimately the question is, hey, if we want to find sine of 15, specifically, how would we figure out exactly where that is? I know we could obviously punch into our calculator, but I like to be exact in my classes. So with that, we have a bunch of formulas here. You can see all those formulas. Go ahead, pause if you need to, copy those all down. They look tough, but I'm going to point out some things here in just a second. But as we look at that, we can see, okay, well, we can think about 15 as a difference. We already know some trig values. We know, sine of 30, sine of 45, sine of 60. So we could go ahead and we could take this sine of 15 and we could think about this as sine of 45 minus 30. Because then if we do that, we can then use, it went blurry. We can then use our difference formula that we have right there. And we can set this up as sine of 45 times cosine of 30 minus sine of 30 times cosine of 45. And then, again, hopefully we have some of these memorized. So we know that sine of 45 is square root of 2 over 2. We know cosine of 30 is square root of 3 over 2. Minus sine of 30 is 1/2 times cosine of 45 is square root of 2 over 2. So with that, now we can just do some math here. So square root of 2 times square root of 3 gives us square root of 6 over 2 times 2 is 4 minus, and then 1 times square root of 2 is square root of 2 over 2 times 2 is 4, which we can then simplify that to be the square root of 6 minus the square root of 2 all over 4. And if you actually went ahead and typed that into your calculator and compared it to sine of 15, we would see it's the same thing. Now, some of you guys might be saying, well, Mr. Keith, I didn't think about 45 minus 30. I thought about 60 minus 45. What if I would have done that? Okay. Glad you asked, fictitious student in the back. Let's do 60 minus 45, and let's see what happens when we do 60 minus 45. So we end up with sine of 60 times cosine of 45 minus, and then sine of 45 times cosine of 60. Got an extra parenthesis in there. Yeah. So let's do that math real quick. Let's see what happens. Well, sine of 60, that is the square root of 3 over 2 times cosine of 45 is square root of 2 over 2 minus sine of 45 square root of 2 over 2 times cosine of 60 is 1/2. Hey, does that look familiar to us? It should, because we end up with square root of 6 over 4 minus square root of 2 over 4, which simplifies to the square root of 6 minus the square root of 2 over 4. So the big takeaway here is it really doesn't matter the pair, as long as it's a legitimate, combination. You can't just do 100 minus 10 and go, that's 15. That doesn't work. But as long as we have that, it's okay. Now, as we look at some of these formulas, hopefully, as you wrote them down, you saw some similarities. I was like right here with our sine, sum, and difference formulas. You can see really the only thing that changes is that sign in the middle. When it's x plus y, it was plus. When it was x minus y, it was minus. When we look at cosine right here, you can see when it was plus, we had a minus in there. When it was minus, we had a plus in there. But it was still cosine, cosine, sine, sine in both those cases. Same thing with our tangent. X plus y, we had a plus on the top, minus on the bottom. Tangent, when it was minus, we had a minus on the top and a plus on the bottom. So we can see there's definitely some similarities in those formulas. So as we go through, I was like, we'll kind of see that, oh yeah, okay, I'm just using a slightly different version regardless of whether I'm adding or subtracting. So with that in mind, I want you to go ahead, take a second, pause, think about, I keep going blurry. Ooh, get your eyes checked, guys. All right, we have cosine of 105. So go ahead, pause, think about that problem, see if you can figure out what the sum is at the very least, how we could add up to that. All right, now that you're back, let's go ahead and for me, I see, well, 105 is 60 plus 45. So I'm just going to go ahead, I'm going to do cosine of 45 plus 60. That's all I'm going to do. I'm just going to do. Now, some of you guys might have looked at that and been like, well, hold on. Couldn't I do 150 minus 45? Because we know cosine of 150 being in the second quadrant. Yeah, you're just going to have some signs that are different, but ultimately you're going to get the same answer. So you could use the sum or difference formula, either one, whichever makes the most sense to you. So as we look at this, again, we can use our formula to say, hey, that's cosine of 45 times cosine of 60 minus sine of 45 times sine of 60. Once again, hopefully we have some of these memorized. We have the square root of 2 over 2 times 1/2 minus the square root of 2 over 2 times square root of 3 over 2. Hopefully you guys are starting to see why I told you should memorize some of those. It makes your life a whole lot easier if you have them memorized. So we have the square root of 2 over 4 minus the square root of 6 over 4, which gives us the square root of 2 minus the square root of 6 over 4. Now, as you look at that, I do want you to think for a second and say, hey, if I have the square root of 2 minus the square root of 6, isn't that going to give me a negative answer? The answer to that is yes, because when we look, hey, 105, that would be in the second quadrant. And since cosine is cosine in the second quadrant is negative, it would make sense that our answer is negative. So again, these things all make sense when we start to add them into the ideas that we've already talked about. All right, let's go ahead and same thing. Go ahead, give tangent of 75 a try at your desk. Again, I know it was kind of a weird formula there, but go ahead and give that one a try at your desks. Hit that pause button. All right, awesome. Now that you're back, to me, 45 is just kind of easily 30 plus 45. Now, if you're saying, hey, I was like, Mr. Keith, how are you knowing these so quickly in your head? Well, I'm just thinking about it. That's all I'm doing. I'm just taking a second saying, okay, well, if I'm thinking about 30s and 45s and 60s, I was like, how can I use that to get to 75? So I'm just thinking about those common angles that we've used so much. So right there, we can go ahead. And again, I know the formula was a little bit complex. It is plus. So that means we have plus on the top. So we'll have tangent of 45 times tangent of 30. Oh, or plus, there, I missed the plus sign in there. 1 minus tangent of 45 times tangent of 30. So with that, I'll go ahead, tangent of 45. Well, that's just a 1. Plus tangent of 30 is square root of 3 over 3 over 1 minus tangent 1 times square root of 3 over 3. Well, the nice thing is with the times 1, I was like, I can basically just ignore that 1, but I do want to make each one of these tops and bottoms into fractions. So, well, 1 is just 3 over 3. So I can go ahead and I can say, hey, this is 3 over 3 plus square root of 3 over 3 over 3 over 3 minus square root of 3 over 3, which I'll then just go ahead and say 3 plus the square root of 3 over 3 times 3 minus the square root of 3 over 3. Well, now I have a fraction over a fraction. So cool, I can go ahead. I can change that into 3 plus the square root of 3 over 3 times, and then multiply by the reciprocal 3 over 3 minus the square root of 3. Well, hey, look, there's a 3 on top and bottom. So I can go ahead and I can just cancel those guys out. And I'm left with 3 plus the square root of 3 over 3 minus the square root of 3. And I always look at it. This is the problem why, we did all that work with square roots back at the beginning to make sure that we go, oh, hey, we can rationalize that. So I can go ahead and I'm going to change colors here. I can multiply top and bottom by 3 plus the square root of 3. Because now if I FOIL that all out, the square roots are going to cancel in the denominator. And again, I'm doing a lot of foiling in my head real quick. So we end up with 9 plus 6 square root of 3 plus 3 for the top over, and then 9 minus 3 for the bottom. So if we combine those like terms, we end up with 12 plus 6 square root of 3 over 6, which, hey, look, we can take a 6 out of everything here. There, if I can point. And we end up with 2 plus the square root of 3. Now, this properly is our final answer. That's what we should simplify to. And that's really why we want to simplify. We want to rationalize and do all this. If you kind of stopped right here before the red, if you stopped right there, I'd be okay with that. Don't tell anyone. I know it's recorded and anyone can see it, but don't tell anyone. So that's the general ideas. Let's go ahead. Let's look at a few more problems that I know will appear on your homework, just so that way we have a good idea of what's going on here. And let's look at cosine of negative 15. Ooh, what to do with a negative? That's a great question. Do you have the answer? Pause and think. All right, so cosine of negative 15. We could go ahead and we could think about kind of subtracting negatives if you wanted to. You could say, we did 15. 15 was 45 minus 30. So I could do negative 45 minus negative 30. I could do that. Or I could think about, I could subtract as well. And I could go ahead and I could say, hey, cosine of 30 minus 45. I could go ahead and I could do that to get to negative 15. So there's a lot of ways you could think about this problem. There's a number of different ways to think about this problem. This is just one example. It's just one example. Don't get caught up if you're texting your friends, because I know you guys text about math all the time. Texting your friend like, hey, this is how I got to negative 15. And if they got to negative 15 a different way, that's okay. As long as you both get to negative 15, the pairs you have don't matter. Feel free to share that tip on social media as you go through this. So cosine of 30 minus 45, we end up, I'm going to do the exact same formulas that I did before. Okay, so I have cosine of 30 times cosine of 45. Now it's a minus, so in cosine, that's actually plus in our formula. And then sine of 30, and then sine, put an extra parenthesis in there, sine of 45. And then once again, we just go ahead. All right, I'm going to do the math here. So I end up with cosine of 30 is square root of 3 over 2 times square root of 2 over 2 plus sine of 30 is 1/2 times sine of 45 square root of 2 over 2. Now, hopefully you're starting to see like, oh, some of these things look very familiar to each other. And yeah, they should, because we're using the same trig measurement. So it only makes sense that we're going to have some similarities as we look at a few of these problems here. Excuse me. So we have the square root of 6 over 4 plus the square root of 2 over 4, which we add those together to write the square root of 6 plus the square root of 2 all over 4. Now, once again, you look at that and you go, wait a minute, we had cosine was negative, but square root of 6 plus square root of 2, that's going to be a positive number. How could that be? Well, let's think about what quadrant would cosine of negative 15 be in. Well, let's see, that would be in the fourth quadrant. So yeah, in the fourth quadrant, cosine is positive. So we should get a positive number when we're looking at that answer. So, all right, one last problem, because I want to make sure we get one of these guys in here. Sine of 565. Ooh, that's a good one there. Take a second. Think about it. All right, so let's go ahead. Now, personally, I don't want to deal with 565. That's way too big of a number. But remember, angles are coterminal, which means I can go ahead and add, subtract 360 as I need. So I can go ahead and let's just subtract 360 from that, and I end up with, this is the same as sine of 205. Well, 205 is a much more manageable number for me to think about here. So now, again, I can just stop and think. Now, it's kind of big, so maybe I want to go, okay, well, let's see. Well, I've used 120 a lot before. So if I used 120, that would give me 75. That's no good. Okay. Well, what if I used, that's the wrong number. I would edit this if I was better, but I'm not going to edit it. Let's do sine of 555. Just like in class, I make mistakes. I'm not perfect. It's okay. Let's go with sine of 505, because now that means if I subtract 360 from that, I'm going to end up with 195. Now, that's a much better number. I don't know what I was thinking when I was doing this. But yeah, okay. So let's try that again. If I did 120 here, that would be 75. I was like, if I can, subtract properly. But yeah, I don't want to do a 75. Okay, so let's think, what else have I used a lot of? I could use 135. I could use 150. I'm going to use 150. I'm going to choose to use 150 here and say, okay, 150 and 45. Hey, 150 and 45. I know that. So I can do sine of 150 plus 45. And again, this is just me spitballing. This is just me thinking about ideas here. Having the right numbers helps, but that's all I did here. So I can go ahead and sine of 150 times cosine of 45 plus, because it's a sum, sine of 45 times cosine of 150. Now, if you need to help you out with this sine of 50 and this, cosine or sine of 150, cosine of 150, if you need to draw a little picture to help you out, go, oh, we're in the second quadrant, think about your reference angle, all that, definitely do that. Okay, so yeah, if I'm thinking about that, hopefully you see, yeah, 150 would be here. And if that's 150, hey, my reference angle is 30. So I'm just thinking about a 30, 60, 90 triangle in the second quadrant. That's all I'm really doing here. So sine of 150, well, sine of 30 is 1/2 in the second quadrant. I know that's a 1/2. And then cosine of 45, well, that's square root of 2 over 2, plus sine of 45, that's square root of 2 over 2. Once again, with a reference angle of 30, cosine of 150 would be square root of 3 over 2. However, it's in the second quadrant. And we all know, that cosine in the second quadrant is negative. So I need to put a negative with that. And that's something else that might change as you do these problems, is you might have to start thinking about, oh, that all students take calculus. What am I doing in what quadrant? So right here, I go ahead and that's going to give me square root of 2 over 4. And then it's a positive times a negative. So it's ultimately going to give me a minus square root of 6 over 4. So I end up with the square root of 2 minus the square root of 6 all over 4. And once again, if I'm thinking about that, hey, 195 is in the third quadrant. Sine is negative in the third quadrant. Square root of 2 minus square root of 6. Yep, that's going to give me a negative number. That answer makes sense as far as my signs go. And that's all we got going on there. So go ahead and give that worksheet a try. If you got questions, shoot me an email. I'm happy to answer those and anything we need. Until next time, stay safe out there, Afton.